This is problem 10.38 in AOPS, Introduction to Number Theory. How many three-digit integers are multiples of both 4 and 6 and have a unit digit of 2? To start this problem off, first let's just define three-digit integers. They range from 100, they range from 100 to 999 inclusive. And then let's just define what it means by being multiples of both 4 and 6. This means being a multiple of the LCM, the lowest common multiple of 4 and 6, which is a multiple of 12. Any number x that is a multiple of 12 is a multiple of both 4 and 6. Further than that, let's just find out what condition of this x that is divisible by 12 lets it have a unit digit of 2. So you do realize that. So if you study some multiples of 12, so when you look at the unit digits, you want to find out. You only look at the unit digit of 12 also. So you have 2. You want to find out what 2 times what is equal to 2, or it gives a unit digit of 2. Realize that 2 times 1 produces a unit digit of 2 for the number. So 12 times 1 produces 12, right? That unit digit is 2. And then 2 times 6 produces a unit digit of 2. 2 times 6 is 12, and 12 has a unit digit of 2. Same thing here, 12 times 6 is 72, which also has a unit digit of 2. So there are only 2 conditions for the multiples, which is that the unit digit of the multiple or the divisor n. So n has to end in 1 or 6. So what's special at 1 or 6? Well, they are both 5. They're both a multiple of 5 plus 1. So you can write n as 5m plus 1, and m is a positive integer, or m is a whole number. So why is that? Because essentially, if you consider this, when m is 0, n is 1. When m is 1, n is 6. When m is 2, n is 11, etc. So on. So it's like 1, 6, 11, 16, 21, 26, etc. So that's n. And when n is equal to 5m plus 1 for some whole number m, then n is a positive integer that has a unit digit of 1 or 6. So therefore we know that n, which is this number, so we know that n times 12, so we know that n times 12 will end with a unit digit of 2. Because as you can see, if n has a unit digit of 1 or 6, it produces a number with the unit digit of 2 when multiplied by 12. So basically here, 12n is our x. So 12n is the number we want, because 12n is a multiple of 12, obviously, and it ends with a unit digit of 2. So what is our range? It's 100 to 999 inclusive. So what's 12n though? If you multiply this, 5m plus 1 by 12, it's just 60m plus 12. Between 100 and 999. So if you subtract both sides by 12, then you get 100 minus 12, which is 88. So 60m is larger than or equal to 88, and is less than or equal to 987. So if you divide both sides by 60, you know that m is between, so 88 divided by 60 is 1. Now, if you round, is a round 1. So if you round 1 up, you have 2. And then 987 divided by 60 is around, so 98 divided by 60 is 1. 60 is, and then 38 is the remainder. 38. So 387 divided by 60 is 6, with the remainder of 27. But let's just leave that alone. So the numbers are between 2 to 16. So if you do the subtraction, it's 12 minus 2 plus 1, which is equal to, there are 15 numbers in total that meet the condition for our question. So that's the answer. So why is that? Because m essentially, so for every different m, there's a different n. For every different n, there's a different 12n, which is a different 3-digit integer. That is a multiple of 12 and has a unit digit of 2. So if there are 15 m's, there are 15 n's, which means there are 15 integers over here that are a multiple of 12, 3-digit, and have a unit digit of 2. So thanks for watching. Bye.